Year 5 and welcome to your very last maths lesson of our home learning. Okay, so next week on Monday we will be in school and then I'll make it 10 times harder for you when we come back. How's that sound? Yeah, that's what I thought. So let's crack on with our final home learning lesson then. So for the very last time, set yourself a 5-minute timer and have a go at these questions. Off you go. Okay, so 2 3/4 is the same as 11 quarters. Okay, so we're making it into an improper fraction. Write a fraction equivalent to 2/3. So if you can remember your multiplication grid, you know that anything that goes 2, 3, 4, 5, 6, 7, 8 and has 3, 4, 5, 6, 7, 8, 9, 10 underneath, it's going to be any of those fractions across. So it could be 4, 6, 6, 9, it could even be 200s over 300. Okay, there are multiple different answers that you could do there. Now work out 64 multiplied by 23, 1,472. And then number 4, what is the value of the 4 in this number? And the value of that number is 40,000, okay, because it's in my 10,000s column, okay. Well done if you got those correct. Any mistakes, okay, go back and just double check where you went wrong and correct them so you know for next time. Now if you've done the time, we can see here that it's 25 to 7. Okay, so it would be 35 minutes past 6. Okay, so it'd be 6:35. And if you did it using our 24-hour clock and did it as PM, it would be 18:35. Okay, so well done if you got the additional time on there as well. So what I want you to do now, do the same thing with pausing the video and giving yourselves five minutes. I want you to see if you can convert these mixed numbers to improper fractions. And these ones here, these fractions here from improper fractions to mixed numbers. Okay, pause the video and have a go. Okay, let's go through these answers. So 5 3/5, sorry. So 5 times 5 is 25. Add the 3. That's going to give us our 25 over 5. So then do 25 over 5. Add 3/5. Okay, it's going to give us our 28. Okay. Here we've got our 3/9. So 3 times 9 is 27. Then we're going to add the 8/9. It's going to be 35 over 9. Now here we're going to do the opposite. So now we've got to turn them into mixed numbers. So you think, well, how many 10s can I get into 102? Are there any left over? And how many 12s can I get into 124? And are there any left over there? Okay, so the first one here is 10 and 2/10. Now we can simplify that to 1/5. Okay. And 124 over 12 would give us 10 and 4/12, which is the same as saying 10 and 2/3. Okay, sorry, 10 and 1/3. Okay, so well done if you managed to get all of those ones correct, because that's going to help you with our times tables today. So let's have a look at this one here. Simple, nice and easy one. We can see our denominators are different ones, so we need to make them the same. Okay, so if we multiply this base number, our denominator, by 2, because we're matching it to 10, we'd have 14 over 10. We're then going to do 14, take away 3, and that's going to give us 11 over 10. Okay, now that is the same if we turned it into a mixed number, saying 1 and 1/10, okay, because we've got 10 lots of 10 that we can get, and then we have the 1 left over. So let's now explore fractions using number lines. Okay, so we can see here that we've got 0, 1 and 2. You might be thinking, well, why have I got it all the way up until 2? Well, if I look closely here, this is an improper fraction. So I have more than a whole. So I have more than 1. So I need to partition it so that I could potentially have 2 wholes in there. Okay. Now I know I'm only going as far as 2 because I know that 2 lots of 5 is 10. And my numerator isn't bigger than 10. Now I've partitioned it into my 5, and I'm going to put here where my 5 holes are, well, where 1 hole is, and my improper fraction for 2, which is 10 over 5. So if I now add on to this one here, my 7/5, so I can see I've got 5 all the way up into here, 6 and 7. Now I need to plot, well, where am I going to put my 3/10? Now I can simplify this, okay, if I change this one here. So I know that that's going to be 7/5. Well, now I need to think, well, how do I work it out in tenths? Well, I know that I multiply this number by 2, so I can split each one of these into 2, so there are 10 equal parts in between. So now I can plot where my 3/10 go. Okay, my 3/10 goes here. So if I now go back to my original numbers that were fifths, I've managed to convert them into tenths, okay? Because we know that 2 lots of the 7 and the 5 is going to give us 14 over 10. Now, ordinarily, all we'd need to do now is work out what the difference is there. And we can see that 7 add 4, okay, gives us 11/10. Equally, we can just do 14 take away 3. 14 take away 3 would have given us 11/10 anyway, okay? Now, again, converting that over, we need to convert it into our mixed numbers, be 1 and 1/10. Okay? So now that you know that, pause the video, have a think. How am I going to work this one out? Okay, so we can see here that I've actually split this into thirds because this original fraction I'm here looking at here is in thirds. Now I've gone all the way to 3 because I've got 2 wholes, but I've got more than 2 wholes. So I need 1, 2, and potentially 3. Now I've partitioned it to 3 because that's what my denominator says. So if I now move this and I plopped it on my number line, this is where I've got 2 and 2/3. Okay, so now what I need to think is I need to now start looking at the ninths. Now I know if I multiply this by 3, that's going to give me my answer here of 21/9. Okay, so this here is now 2 and 6/9. Okay, because I've got 1 whole lot of 9, 2 lots of whole 9, 1, 2, 3, 4, 5, 6. I've now had to convert that one now so that it's 2 and 6/9 as well. So now I'm going to plot on my 7/9. And I think, well, how do I now get from here to here? Okay, so if I now jump this, that's 2/9 to get to a whole. Then I can add an entire whole fraction of 9s, and then I have an additional 6. So all I need to do is then add all of those together, and that's going to give me 1 and 8/9. Okay, equally though, we could have done the normal thing where we converted that fraction, so rather than it being 2/3, it could have been 6/9, and then we could have done 6 take away the 7. We know that 6 take away 7 is going to take an extra one off the whole number, so it's going to become 1 less within the whole, plus that -1 there. Okay, so now that you've done that, please have a go at doing questions 1 to 3. Now numbers 1 to 3 do show the number line, and I know there are going to be a lot of you sat there at home right now or at school thinking I don't like the number line. That's fine. Okay, if you want to be able to have a go at working out the fractions the way you know how, okay, and you know to take your whole numbers away and you know to convert your fractions, by all means, go for it, okay, whatever gets you to the right answer. Okay, so pause the video and have a go at questions 1 to 3. So let's have a look at a problem solving question. So a race is 3 2/3 of a kilometre in length, okay, so this is the length of it in total. Annie has run 1/6 of a kilometre of it so far. So we need to work out how much further does she have to run, okay? So pause the video and have a think. What might I need to do to be able to work out this question? Okay, so I need to have a look at converting. So here I've got my 3 wholes and my 2/3. Now I can see here if I go look at my 3 and my 6, okay, I can change this to 6. So I can multiply this by 2. Okay, if I multiply by 2, it's going to give me 4, 6. So here I can see I just have to do 4, take away the 1. 4 take away the 1 is going to give me 3 and 3, 6. Now I'm looking at this and 3 and 6 here. I know that these are both multiples of 3, so they're divisible by 3. So I can actually simplify that so that it is 1/2. Okay. So on that basis, let's have a look at these missing number ones. Now I know you all love missing ones, okay? So let's have a go at these ones. So we can see here that our common denominator here is 30. So we need to multiply this one so that our denominator is different. So I need to think, well, to get from 6 to 30, we multiply by 5. So my denominator has to be within 30. So now I'm thinking to myself, whatever these two numbers are, taking them away from each other is going to give me the answer 7. I don't need to worry about my whole numbers because they're equal on both sides of my fraction. So I don't have to worry about those, but these two numbers have to total when I subtract them to 7. So what if I just went about and put 14 and 7 in here? Okay, do you think that would be a correct answer? No, potentially not, because I know that 14 take away 7 is 7. So in that respect, it's right. But I have to remember I then need to make this 5 times smaller because I multiplied it originally. So to find out what the original number was, I've then got to divide it. Now, if I did 7 divided by 5, I'm going to get myself a decimal answer. And we know with fractions, we have to have whole rounded numbers. So I can't have a decimal in there. So that's not going to give me the right answer for that missing box. Okay. So I now have to think to myself, I need to think of something that is a smaller number, okay? So I need to think, well, 5 here, I could have 1, because I know that 1 multiplied by 5 gives me 5. Okay, so we'll start off with just the smaller version. So I've gone for 1/6. So let's just do it as trial and error. Let's see if it works. So I'm now thinking, well, what take away 5 is going to give me 7? Okay, so if I add 7 and 5 together, it's going to give me 12, isn't it? Okay, so therefore 12 take away 5 is 7. Now that works. And equally, if I then divide 5 by 5, that gives me 1. Okay, so these numbers now all match. Now you might find there are other variations of these numbers that you could do as well. Okay, and it's usually looking at these two here. What two numbers could we take away? And then you can match that number. So pause the video and have a go. See if you can come up with another alternative to some missing numbers. Okay, well I had a go at this one here and I thought, well, I could do 2. Okay, because I know that 2 times 5 is going to give me 10. So I think, well, what take away 10 is going to give me 7? So let's do the inverse. 10 add 7 is 17. So that means there that my number there would be 17, because that would be the same as saying 17 take away 10. Okay, once I've converted that number, then 17 take away 10 would give me 7. Equal, I could do it, so I could do 3. And then I'd have 3 times 5 is 15. I'd think, well, 15, something take away 15 is 7, and it would be 21. 21 take away 15 would give me 7. So I can go as far as up to 5, 6, and that could give me any variation of the number here, as long, however, as long as it doesn't go beyond 30. Okay, so that's where your limit is. Okay, so you might have had some different numbers as long as it doesn't go above 30. So let's look at this problem solving question here. This one's an easy peasy one, okay? And I think the number line might make it look a bit more complicated than it actually is. So you do what works for you. So Alex cycles 8 kilometres and Mo cycles for 7 kilometres and 5/8. So we need to work out, well, how much further does Mo need to go? Okay, how much further does Alex cycle than Mo? Well, this is an easy one. And I don't think we need the number line for this one, because we know we've got 7 whole lots of 8s and Alex cycles 8 lots of 8s. So I just have to work out what I would need to add to this fraction to get me to 8 whole lots of 8. So I can just think, well, to get from 5 to 8 is going to be 3, isn't it? So let's double check using the number line, okay? So we can see here the difference between them, like I just said, is 3/8, okay? Easy peasy, because I've already got 7 whole lots. Whatever I'm going to add on to here is going to give me another whole one, and that's going to round me up to 8, and that's how far Alex cycles. So I just had to count the difference, okay, for what was left over. So let's consider it in this context then. Jack eats 1 whole and 2/5 of a pie. Dora eats 9/10 of a pie less than Jack. So she eats less of it than Jack does. Okay. So how much pie does Dora eat? So let's put this on the number line. Okay. So I could convert this, so my denominator is the same, to 1 and 4/10. Okay. So if I plot 1 and 4/10, it's here. Now Dora eats 9/10 less. So we've got to subtract 9/10. So if we then count it backwards, okay, here we can see we've got 1, 2, 3, 4, 5. It'd be 5/10. Okay, now we can convert that, okay, to a half, okay, because it's equal to. So Dora only eats half of the pie, okay, whereas Jack has eaten a whole pie and an additional 2/5 of his pie. Okay, easy peasy. Okay, if you don't think the number lines work for you, don't even bother with the number lines. You know how to convert your fractions. Once you've converted them, it's easy enough to take away those numbers. Easy as pie. See what I did there? That was a good idiom, that was. I think that was an appropriate idiom there. Rather than a piece of cake, it was easy as pie, because, well, it's about pie. What can I say, Year 5? I'm just amazing. Just amazing. So, now that I've thrown you off topic a little bit, have a go at doing questions 4 to 6 on your worksheet, okay, and see how you get on. And that Year 5 is the end of our maths learning at home. So you can do yourself a nice little dance, a little boogie. So when we come back on Monday, I'm not sure whether we're missing maths, because there is a lesson that we're missing first thing on Monday morning, but I can't remember off the top of my head what it is. But when we come back either on Monday or Tuesday, we're going to carry on with our fractions topic, but we'll finally be able to do it in school and have it all done in our maths books. And if you do get stuck, I'll actually physically be there to be able to help you with it, okay? So good luck with that maths work, and I look forward to teaching you properly face-to-face next week. All right, good luck, Year 5.